now let's look how we're going to use our units of measurement and the knowledge of our derived units to actually solve volume and density problems. So first we have to remember what volume and density are. Remember, volume and density are your derived units. They're measured in liters or meters cubed or a volume cubed. For volume, remember 1 milliliter can equal 1 centimeter cubed. And for density, it's grams per centimeters cubed, or basically grams per milliliter. Those are the two common ones we use. So what is actually volume? It's for liquid and gas, you're going to measure in liters. For solid measurements, you're going to measure in units of measurement cubed. So meters cubed or centimeters cubed. And please, again, remember, a really important piece of information is 1 milliliter equals 1 centimeter cubed. The definition is the liquid amount or the amount of volume a solid, liquid, or gas will take up. The formula, if you're given units of measurement for solids, is length times width times height, because you've got to remember your units are going to be cubed, or you can use water displacement for items like in a graduated cylinder for irregular objects like a toy car or a ball. And that formula is your ending amount minus your starting amount. Okay, so let's look how we might solve a volume problem. So we're given the problem. What is the volume of a box given the height of 6 centimeters, a width of 7 centimeters, and a length of 10 centimeters? Well, the first thing you can do is what I did. I just underlined the given information, because in math word problems, sometimes there's a lot of words that can mean similar things. So I just underline them. And then for step 1, you're going to outline the given information. You were given a length of 10 centimeters right from the problem, a width of 7 centimeters right from the problem, and a height of 6 centimeters right from the problem. Then you have to make sure that all the units are the same. You can't have meters and centimeters mix. You either have to be all meters or all centimeters or whatever unit of measurement that you're going to be using. If they're not all the same, you have to make them all the same. And you can use that using metric conversions, which we will cover coming up. Then you have to set up the formula. The formula is length times width times height. Then you're going to plug it in. 10 times 7 times 6 gives you 420 centimeters cubed. Please do not forget to cube the units, because centimeters times centimeters times centimeters gives you centimeters cubed. Okay, so let's look at another type of problem, the one that is using a graduated cylinder for an irregular shaped item. So again, we're going to go ahead and underline the information given. So a toy car is placed into a graduated cylinder. If you see a graduated cylinder, you almost always know it's going to be a regular shaped object, and you're going to be using the displacement method. Before the car was placed into the cylinder, the meniscus read 17 milliliters. If you don't remember what the meniscus was, it's that lowest point of a curve when you're reading it. So you always read at the meniscus. After the car, the meniscus read 28 milliliters. What is the volume of the car? So remember, your first step is to outline given information. You were given a starting volume of 17 milliliters and an ending volume of 28 milliliters. Then you're going to set up the equation, plug in, and solve. So ending volume, 28 milliliters, minus starting volume, 17 milliliters, equals your volume of your object. So 28 milliliters minus 17 milliliters gives me a volume of 11 milliliters. Okay, so now let's look at density. Remember, we talked about density being a ratio comparison of mass to volume, and it's the same for any amount of a substance. The formula is mass over volume, but please remember these items. Mass needs to be in grams, and the volume can be either in liters, milliliters, centimeters cubed, or meters cubed, and the unit is going to be grams over your volume unit. So if you're good at using a formula to get the different formulas out of it, or flipping it around to find your missing variable, you can just remember D equals M over V. But I have this handy dandy equation triangle, and if you can remember the equation triangle, then you really have every formula you need for density. So how you work the equation triangle is you cover up what you're looking for. So if we're looking for density, we can cover up density. I'm going to put an X through it. And then your formula is left for you. So density is mass divided by volume. That's the formula that is left. So if we're looking for mass, we would cover up mass. And the formula is density times volume. And if we were looking for volume, we covered that up. And we're left with the formula mass divided by density. So in one easy step, we can find all three main formulas for the density equation. Okay, now I want you to remember that density has heart. If you've completely forgotten the formula for density, just simply draw a heart and draw a line for it, and then boom, formula. So draw a heart, put a line through it, and now you can see that this shows you it's M over V. Density has heart. Okay, let's solve a problem using density. So let's solve a density problem. So the first thing you have to do is read the problem. So what is the density of an object that displaced water? When you read that, you know you're not going to be using length times mass times width. You're going to be using the displacement method from 5 milliliters to 12 milliliters and is 49 grams on a triple beam balance. Remember, a triple beam balance is a measurement tool that gives you mass or weight. So step one, you're always going to outline the information given. We were given a starting volume of 5 milliliters, an ending volume of 12 milliliters, and a mass of 49 grams. Your step two for densities is often you either have to find your mass or your volume. So you have to solve for that before or both in order to solve for density, because remember you need both mass and volume for density. So my volume is 12 minus 5, which is 7 milliliters. We're using that displacement method. And then you're going to set up the formula using your equation triangle. You're going to set up this formula for whatever you're solving for, then you're going to plug in and solve. So density equals mass divided by volume. So my mass was 49 grams right here. The volume we solved was 7 milliliters right from step 2. So I end up with a density of 7 grams per milliliter, grams per milliliter. Okay, let's do a volume problem solver. So what is the volume of water in a pool if it measures 8 meters across, 20 meters long, and 3 meters deep? So how you solve it is you set up your equation, which is volume equals length times width times height. We're using that because it wasn't displacement. So your volume is 8 meters times 20 meters times 3 meters. 8 times 20 times 3 is 480. Remember, meters times meters times meters is meters cubed. Don't forget your cubic unit of length if you're using this method. Let's do another volume problem solver. A student wants to measure a marble, so he takes out a graduated cylinder. He carefully measures out what appears to be 10 milliliters, but when he reads the meniscus, it is really 9.5 milliliters. The student places the marble into the graduated cylinder and the water level rises to 16 milliliters. What is the volume of the marble? Okay, so when you see the word graduated cylinder, please remember you're looking at the displacement method. So the displacement method says your final minus your starting. But we didn't start at 10, we started at 9.5. So volume equals ending reading minus starting reading. So 16 minus 9.5 gives me an ending result of 6.5 milliliters for the volume of the marble. Okay, let's do a density problem solver. What is the density of a cube whose sides are each 5 meters or centimeters and that measure 4 grams on the triple beam balance? Okay, so don't forget I gave you a cube whose sides measured. So you got to find the volume first. So 5 times 5 times 5 is 125 meters cubed. So you got to find the volume, and then you took your grams, 4 divided by your volume, 125. I know I switched to centimeters cubed here, pretend it's meters cubed, and you end up with 0.032 grams per centimeters cubed. If you got like 0.8 or some of those bigger numbers, It's not that you were doing the equation wrong, you're putting your mass and your volume in the right spot, but you were forgetting to take your side and multiply it out and complete your volume formula, and that is a common mistake. Okay, final density problem solver. What is the volume of a cube whose density is 25 grams per centimeters cubed and the mass is 5 grams? So let's look at how we would solve that. So remember, we're not solving for density, we're solving for volume, which means you have to cover volume on the density triangle and you're left with an equation of mass over density. Or you can go ahead and rearrange your formula. We were given a density of 25 grams per centimeters cubed, and we were given a mass of 5 grams. So 5 divided by 25 leaves me 0.2 centimeters cubed. And that is how you solve for density and volume.